Hey guys, so I want to take some time and kind of walk you through another tool that might actually help with this process of working through some calculations, and that's dealing with a mole roadmap. So, with a mole roadmap, first of all, on your paper, you want to go ahead and write these down here for this first example. On this mole roadmap, get my notes over here real quick. Sorry, we're gonna use this as sort of a guide to work through some of the calculations. Okay, some of the calculations are a little bit tricky in terms of setting them up. This might serve as a visual to help with that. So you apologize while I look down here a little bit. If we start with mass, for example, you're given 16 grams of something, and you want to find out how many moles it is, or perhaps how many particles it is. In this case, usually we're talking about atoms. What we're going to do is we're going to take 1 mole of something and put that over the molar mass. And of course, the molar mass you find from the periodic table. If, however, you're going from moles to the mass, we'll actually switch that. We'll have the molar mass on top over 1 mole. So if you could go ahead and write this on that very first mole roadmap that you have on your paper. Okay, go ahead and write that portion in. Now, over here on the right, we have number of particles. Now, that could be, honestly, that could be anything. That could be atoms. It could be molecules. It could be compounds. It could be ions. Anything like that. It doesn't matter what it is. It's how many of them are there. And to do that, since we are comparing everything back to the mole, we're going to use Avogadro's number. So going from the mole, counting the number of particles, we're going to use 6.02 times 10 to the 23rd particles in every 1 mole. Okay, but if we're going from particles over to moles, then we're going to use 1 mole divided by 6.02 times 10 to the 23rd particles. Now, this mole map becomes useful when we've got to do multiple different steps. So, for example, if you're given the mass of something and we want to know how many particles there are, we can see that we first need to go from mass to the number of moles, and then from the number of moles to the number of particles. So we would follow this highway going this direction. If, however, you're given the number of particles, we then go from particles to moles, and then moles to the mass. Okay, so we can use this mole roadmap a number of different ways. Now you see at the top, there's an area for volume. We'll get to that one later. So let's turn our attention to the examples. Now we've got 4 different examples that I want to walk you through. So on your paper, go ahead and follow along with each one of these, and you're going to need to write in those same examples or write in the answers as we go along. So if there are 4.9 times 10 to the 6 atoms of tin, how much does this weigh? Okay, so we're starting with the number of particles, and we want to find the mass. So let's start with our number of particles. Always begin with your given over 1. Okay, in this case, we are given 4.9 times 10 to the 26 atoms of tin. Okay, we always start with our given over 1. So right over here, our given is a number of particles. We first want to go from particles to moles. So to do that, we're going to go ahead and bring in our next conversion. We want to get rid of atoms. We know that there are 6.2 times 10 to the 23 atoms in 1 mole of tin. So we've just gone from number of particles up to the moles. Now we want to go from moles to the mass. So every 1 mole of tin is how many grams of tin? And that we need to look up on the periodic table. Now we see here that tin is element number 50. So I'm going to look over here on my periodic table. I find tin. I see that its mass is 118.71. So it's 118.71. And then from here, we do the math. Now I know I kind of jump over this math part of it kind of quickly. The expression is